Last meeting, I started how to calculate deflection slope using virtual work methods, method for beams. And I give you few shapes of bending moment if you have simply supported beam between hinge and roller and you have concentrated load, simply supported beam with distributed load, simply supported beam with concentrated moment at one end. And the second case, if you have cantilever with the concentrated load, cantilever with distributed load, cantilever with concentrated moment. What will happen if you have this cantilever attached to this beam? Okay, go ahead and draw the bending moment for the cantilever. Looks like one, like this one, or this one, or this one. And then go ahead and connect it to 0, 0, and 0. What will happen if we have many load like this one? We have concentrated load and we have distributed load. So I'm gonna assume we have this concentrated load alone and draw bending moment diagram, and I will assume this distributed load alone and draw bending moment diagram. So the final diagram, I will add this diagram plus this diagram in one diagram at the end, which called bending moment diagram using superposition method. And I covered, by the way, the steps for visual work for beams. We have 4 steps. The first one, draw bending moment diagram. The second step, remove and put unit load or unit moment, draw bending moment diagram, and then go ahead and make integration. If you would like to do integration, we have this table of integration. Whatever the shapes, if you have rectangle with rectangle, go ahead and use this one. If you have triangle with triangle, go ahead and use this one. If you have triangle with rectangle, go ahead and use this equation. By the way, this value is m bar, this value is m, and this length is L. And I covered, I think, 2 examples. Let's start to cover this example. We need to determine the deflection y and slope theta at point B. This point. By the way, this cantilever is fixed at A. We have fixed at A only. So first step, we need to draw bending moment diagram, which is called M naught. I believe this cantilever, which is fixed at A, and we have uniform distributed load, looks like this case. Cantilever fixed from one end, and we have uniform distributed load. So we have this triangle, and the value of moment here, WL squared divided 2. And this parabola, the maximum moment here, WL squared divided 8. Let's do it. So bending moment diagram will be this triangle. The value of moment here, WL squared divided 2. What is the value of W? Just a second to grab my calculator. W is 12. L square 10 square divide 2, so the value will be 600. And we negative. And we will have parabola. The value of moment here equal W L square divide 8. The value of W 12. L square 10 square divide 8. The value will be 150. This is the first step, bending moment diagram, piece of cake. Piece of cake. and I told you last meeting, it's okay, I'm giving you a permission. You can open your note to figure out what is the shape of your bending moment diagram based on which situation you are in. That makes sense? Okay, this is the first one. Second step, I will remove everything. I will remove all applied load. So I will remove this distributed load. We are looking for deflection at B. I will start with deflection at B. Just to remind you, just a reminder, if you would like to figure out what is the value of deflection, go ahead and put unit load. So I will remove everything at point B. I will put unit load 1. I will assume this unit load to go down. It's up to you. So go ahead and draw bending moment diagram D2 the unit load. I believe this concentrated load on this cantilever fixed from one end, you will have bending moment diagram looks like this triangle. The value here will be P times L. In this case, P equal 1 and L equal 10. So the value here will be 10. Negative. This moment called M1. I think if you would like to figure out the deflection at point B, you need to make integration for M naught with M1 divide EI DL. Get EI outside the integration because it's a constant. How can I integrate M naught with M1? What do you have in M naught? We have this triangle. I would like to integrate this triangle with this triangle. Let's do it. Triangle with triangle is 1/3 M times L. So 1/3, the value of moment here, negative 600. Time M, the time of moment here is negative 10. Time L, the length of the beam is 10. This is the first diagram. This triangle with this triangle. One more time. We have this parabola by this triangle. We have here two diagrams with this triangle. So I need to do integration between this triangle and this triangle, and between this parabola and this triangle. Let's do it. Plus parabola with triangle. Do you have here complete parabola? We don't have complete parabola. If you don't have complete parabola, I give you a hint last meeting how to do complete parabola with triangle. It's very easy. It's not included in this table, so you need to remember it. I will get the area of this parabola. Do you remember what is the area of this parabola? Yes, I remember. 2/3. I will assume I will have rectangle here. So 2/3 times 10 times 15. This parabola is positive. The area of this parabola is positive. At this centroid of the parabola, we have a corresponding value here of moment equal 5. Have 10. It's negative 5 because this diagram is negative. Go ahead and find your number. So guys, the first part is integration of this triangle with this triangle. The second part is integration between this parabola and this triangle. if you have a complete parabola, one more time, if you have a complete parabola with triangle, and this case is not included in this table. The case here, we have half parabola. Okay, we can do it very simple. Go ahead and define the area of this parabola, which is 2/3 area of this rectangle. Multiply this area by this value of moment. Make sure every diagram will take the sign. So if this diagram is positive, the area will be positive. If this diagram is negative, the value here will be negative. Make sure you are familiar with this situation. So your value will be 2/3 times 10 times 15 times -5 plus 1/3 it will be positive 19,500 divide EI. 19,500 divide EI. This value plus this value. Anybody can tell me, this is the question I asked last meeting. Anybody can tell me what is the meaning of YB deflection at B equal positive? Anybody remember what is the meaning of positive deflection in virtual work? Do you remember that? Assumed right direction. Okay, what is the right direction? What is the direction that you assumed? I assumed unit load going down. This assumption is correct. So this deflection will go down. I am done with the first part of the problem, deflection. Second part, slope at B. Just a hint. M note was parabola and triangle. The value of this parabola 15, this triangle 600. Negative, positive. This is the bending moment diagram due to the given load, M note. Right now, I'm looking for a slope at B. Okay, I will remove everything. At point B, I will add unit moment. Unit moment. If you are looking for deflection, I will put unit load. If you are looking for slope theta, I will put unit moment. I believe this cantilever with this moment looks like this case. This case. So your bending moment will be 1 down at the head of the arrow, and this one will be constant, negative. This is M1. If you would like to figure out the slope theta at theta at B, you need to do integration between M naught by nu M1 divide EI DL. 1 over EI outside integration. Remember, in M naught, we have two diagrams. So we have this triangle with this rectangle. What is the case? Triangle with the rectangle. This is the case. So we have 1/2 times M times M times L. 1/2 time this M negative 600 time this M negative 1 time this length L10. This is the first integration. This is the first integration. Please don't forget your sign. If your moment is negative, keep it negative. If your moment is positive, okay, take it positive. Plus, we have another integration between this parabola and this rectangle. Unfortunately, we don't have complete parabola in this table, so I will do it by hand. The area of this parabola, 2/3 times 10 times 15. The centroid of this parabola, the corresponding value here will be -1. So guys, keep in your mind. One more time here. If you have parabola with triangle, if you have parabola with rectangle, the same scenario. The area of parabola time the corresponding value for this centroid, this value. The area of parabola time the corresponding value for this centroid, this value. So if you multiply this area by this value, you are doing integration between this shape and this shape. If you are multiplying the area of this parabola by the coordinate value here, you are making integration between this parabola and this triangle. Anyway, so the value here will be 0.5 times 600 times 1 times 10 plus 2/3 times 10 times 15 times -1. We will have positive 2,900 divide EI. My question is, what do you think? The value of theta at B equal positive 2,900 divide EI. What is the meaning of positive? Means you assumed this unit moment correctly. I assumed it clockwise. It's correct. Clockwise rotation. That makes sense? That makes sense? Any question? Guys, any question so far? If you have any question, let me know. I think this method is very important and very easy. Very important and very easy. One more example. The last example in this method for beams. We need to determine the slope theta and the deflection y at point A. We have another cantilever fixed at B, and the applied moment is 4 kilonewton-meter. Do you remember what was the first step? First step, we need to draw bending moment diagram, which is called M node due to the given load. We have only this concentrated moment, so I will put here value 4 at the head of this arrow up, and this value will remain constant to the end of the cantilever, positive. This is the shape of M node. I will start with slope at A. So the next step, I will remove everything. And at point A, I will put unit moment. Can you draw bending moment diagram due to the unit moment? Yes, I can. The bending moment will be, we have value here 1, will follow the head of the arrow down, and this value will remain constant. negative. This is M1. Do you like to calculate the value of theta at A? Yes, I need. Go ahead and make integration between M naught and M1, divide EI dl. Put 1 over EI outside the integration because it's a constant. Go ahead and start to make integration. The case right now, we have this rectangle with this rectangle. Okay, sounds good. Go to your table of integration. We have rectangle with rectangle. So the integration value will be m times L. Very easy. So the value of m here is positive 4. The value of m here is negative 1. The length of the beam is 3 meters. That's all. What is the value of theta? Will be negative 12 divide EI. My question is, what is the meaning of negative value? You assumed wrong rotation or wrong direction for the unit moment. So I assumed it counterclockwise. Counterclockwise. I'm sorry, it's wrong direction. So your rotation will be clockwise. That makes sense? You don't need to change anything. You need only to tell me what is the correct direction. The next part of the problem, we are looking for deflection at A. So deflection at A. Just a reminder, this shape is the bending moment diagram M naught. This one will remain the same, M naught, because this one due to the given load will remain the same. Then I will remove everything from the beam because I'm looking for deflection at A. So at point A, I will put unit load. This time load, not moment. Unit load. I think we are right now in the case of cantilever with concentrated load. So the bending moment diagram looks like this triangle. The value here will be P times L. P equal 1, L equal 3 meters, I think. That's right. Yes. So the value of the moment will be 3. Negative. If you would like to if you would like to figure out the value of deflection at A, you need to do integration between M naught and M1 divide EI dl. Put 1 over EI outside. Go ahead and do integration. This time, we have integration between this rectangle and this triangle. Open the table of integration. We have triangle with rectangle. So 1/2 MML. 1/2 this M positive 4. This M negative 3. This L 3 meters. So the value will be negative 18 divide EI. Anybody can tell me what is the meaning of negative value of deflection? Means you assumed wrong direction. I assumed the unit load going down. I'm sorry. This point will move up. And that makes sense. That makes sense. Because this moment trying to rotate this beam up. So I believe the deformed shape of this beam looks like this. So this point will move up. That makes sense for me. Anybody has any question? Guys, do you have any questions so far? Anybody has any questions so far? So, last meeting and today, the meeting, we covered visual work for beams. It's very important to be professional on how to draw bending moment diagram using superposition method and how to use this table of integration. The only case which is not included in this table, if you have a complete parabola with triangle or with rectangle, it will be very easy. Just get the area of the parabola, multiply this area by the corresponding value to the center. You can get the integration. Anybody has any question? Guys, do you have any questions so far? Any question? Okay. I will start with the last part in this topic for visual work for trusses. Just for your information, for trusses, we don't have rotation. We don't have slope. We don't have theta. We don't have theta because we don't have moment. If you go back to chapter 3 or chapter 3 or chapter 4, I think, for trusses, we don't have moment. We have only axial force. So we don't have theta. We have only vertical, sometimes horizontal deflection. To show you what's going on, I would like to explain this example using RISA 2D. We have truss, 3 members, roller at A, hinge at C. Guys, I will show you something professional today, so please pay attention to me. So if you go back to RISA, first step, I need to assume origin. So I will assume this point, my origin. Here is X and here is Y. So your coordinates will be, I will need coordinate at 0 and 0, coordinate here at 0 and 6, coordinate there will be 8 and 6. The member of this truss consists of double angle 5 times 5 times quarter inch. We don't care what is the meaning of this double angle. We don't care about this right now, or at least this semester. So let's start. Where is RISA 2D? Here you go. I don't like to show up this drawing grid, so I will hide it. Insert, joint, 0, 0. The second one at 0 and 6, I think. Yes. The third point will be at 8 and 6. Here you go. We have 3 points only. 3 points. Insert, members, hot rolled. I will open this little button. I said it's a double angle. The cross section is double angle, and it's double angle 5 times 5 times 1/4. So I will look here, 5 times 5 times 1/4. you can pick up any 5 times 5. We don't care about the third one, so I will pick up this one, for example. Okay. Apply. Oh, I forget something very important. I forget something very important. You remember it's double L, double angle LL, 5 times 5. I forget. Do you remember what I forget? Anybody? Any answer? Unit. We are in feet and pound. That's fine. So the default unit in RISA is feet and pound. This is the default. If you have unit meter kilonewton, no, you need to change your unit at the beginning. So we are in a good phase right now. No, I have another issue here. Anybody know what is the other issue? Anybody know what is the other issue before starting to draw members? Anybody remember? Nobody remember. Nobody. Yes, yes. Thank you, Marcus. Thank you so very much. Yes, we must highlight or select this option. Bend at both ends. If you don't select this option, believe me, you are not drawing truss. You are drawing something else, beam or frame. You have to select bend at both ends. Apply. Go ahead and draw your members. Any questions so far? Looks good. We have hinge at C. So insert boundaries hinge or pin, apply at C at this point. Please pay attention to the next support at this point. What is the type of support at A? It's roller. Let me ask you a question. What is the difference between this roller and this roller? Anybody can tell me what is the difference between the two rollers? Anybody can tell me? I have case number 1 and the case number 2. What is the difference between roller in case number 1 and the roller in case number 2? Thank you. Looks like you can understand what is the difference. This one, your reaction will be like this. This one, your reaction will be like this. Does that make sense? Does that make sense? This one can move vertically. This one can move horizontally. That makes sense? Looks good. So what is the case? We have horizontal reaction and we have movement in the vertical direction. Anyway, so insert boundaries. Here is the roller. Wow. Wow. We have issue here. The default roller in RISA, the default one, will give you Y reaction and free reaction in X. This is the default roller. But this is not the case in our truss. In our truss, we have horizontal, which is X reaction, and the free in Y. How can I solve this issue? Guys, are you paying attention to me? We have issue here is the default roller in Riza will give you vertical reaction all the time. Y reaction. And the free horizontal reaction. But this is not the case in our truss. Our truss need horizontal reaction and the free in vertical reaction. How can I solve this issue? The issue can be solved. Don't choose roller from here. What should I do? Go ahead and create your own roller. So for X translation, I have reaction. For Y translation, it's a free. Apply. Click at this node. You create your own roller. We have concentrated load 150. So insert joint load, your unit here in kip. So it will be negative 0.15. Apply, click at this node. Here you go. Then spreadsheet load combination. Enter. For basic load case, I will select basic load case 1. Your scale factor is 1. I'm done with this step. I will start to solve. Okay, we learned this before, that we can show up the axial force. I can show up the X reaction, Y reaction. All of this stuff looks good. All of this stuff looks good, but this is not our topic right now. Our topic, I would like to show you the deformed shape. Looks like the deformed shape is very, very small. So I will do magnification factor 4,000, 10,000, 20,000. Okay, 20,000 will be good. Looks like this is the deformed shape. Can you see? That makes sense for me because this load will push this point down. If you go to results, joint deflection, the value is very, very small. Okay, let me insert joint load. The value here, I will make it bigger, 15, negative 15. And solve. Yeah, it will be very, very small, very big. So I will go back to the magnification factor to be 1,000. Smaller, 500. Okay, looks good. If you open results, joint deflection, here you go. Can you see node number 3? Anybody can see node number 3? We have X horizontal movement, 0.005 inch. Positive means to right. In Y, we have negative 0.024 inch. Negative means down. So this point moved horizontally 0.005 inch. Vertically, negative 0.024 for truss. we need to learn how to calculate this deflection for trusses. And I told you for any joint in truss, probably we will have horizontal and vertical deflection. Any question? Any question? Okay, I will use virtual work to do this. We have 4 steps, and I have surprise for you, for a student who left truss in the first exam. The first one, we need to use method of joint to determine the internal force in each member of the truss due to the given load. This is the first step. First step, we need to solve the truss. We need to find the internal force in each member. We need to define or find the internal force in each member due to the given load. The next step, I will remove all external load, and I will place unit load at the joint where the desired displacement is to be determined. And keep in your mind, if this is the case of the truss, and this joint called A, if you are looking for vertical deflection at A, I will go to A and put unit load. If you are looking for horizontal deflection or displacement at A, horizontal, I will go to A and put horizontal unit load. That makes sense? So please, second step, I will remove all external load and I will put unit load. This unit load can be vertical or can be horizontal based on what is the required in the problem. If the required is vertical deflection at this joint, I will put the unit load vertical. If the required is horizontal deflection at this joint, I will put the unit load as horizontal load. The third step, I will solve the truss one more time, but due to the unit load. And this internal forces in the truss will be small n. The final step, your deflection, horizontal or vertical, whatever, equal summation n time L over EA. And this calculation will be done in a table. You need to set up your calculation in a table. Let me do an example, and I will continue next meeting. We have truss, and we need to determine the vertical deflection at B using virtual work. Okay, regardless what is the required, first step, I need to solve this truss. Chapter 4. To solve this truss, I need to figure out what is the reaction. We have here reaction XA. We have here reaction XC. We have here vertical reaction YC. To figure out the reactions, if you apply summation f of x equals 0, summation f of y equals 0, summation moment at any point equals 0, I believe this reaction will be 150 times 8 divided 6 This reaction will be 200. This one will be 200. And this one will be 150. Then, for joint B, here is joint B. We have vertical load 150. We have horizontal member. We have inclined member. So I will assume this one tension and this one tension, and this angle is theta. By the way, this one is 8, this one is 10, this one will be, I'm sorry, this one is 8, this one is 6, this one will be 10 feet, and this is the angle theta. So I can figure out the value of sine theta equals 6/10, cosine theta will be 8/10. Okay, go ahead and apply for joint B, summation f of x equals 0. So this value will be FBC. This value is FBA. So negative FBC, negative FBA cosine theta equals 0. Apply summation f of y equals 0. We will have negative 150, negative FBA sine theta equals 0. I think I can get value from the last equation. Sine theta is 6/10. The only unknown here is FBA will be negative, how much? 250. Negative means you assumed the wrong direction. I assumed that this force tension. I'm sorry, it's a compression. Go back and put here FBA negative 250. I can figure out the value of FBC. It will be positive 200. Positive means I assumed the correct direction, which is tension. So this one will be tension. This one will be tension. How much? 200. This one will be compression. This one will be compression. How much? 250. Because it's a compression, I will put it negative. If you do joint equilibrium at C, I will find this one will be tension. How much? 150. Positive. Positive. Any force tension will be positive. Any force compression will be negative. So the first step, I solved the truss due to the given load. So these forces can be called capital N. So guys, the first step in your calculations, we need to solve the truss. We need to find the internal force in each member. And make sure if your member is in tension, the value will be positive. If your member in compression, the value will be negative. Keep it in your mind. Any questions so far? Wow. Looks like first step. The first step in this method will be what we are doing or what we were doing during chapter 4. Next step, step number 2. Here is the truss. I will remove everything. So everything removed. Reactions, any external load, everything removed. We are looking for vertical, make sure, vertical deflection at B. Here is point B. Because I'm looking for deflection at B, vertical deflection at B, I will put unit load at B. 1. That makes sense? Please go ahead one more time and solve the truss one more time. D2 unit load 1 bound. With this force inbound, so this unit load will be inbound. Okay, go ahead. We have reaction here. We have 2 reactions there. I think this reaction will be 1. I think this reaction will be 1.33, and this reaction 1.33. This force will be compression. This force will be tension. This force will be tension 1.33. I think this one will be how much? 1.67. So solve the truss one more time to find the internal forces in each member. And I did in my mind. These internal forces, tension 1.33, tension 1, negative 1.67, I will call it small n. Any question so far? This is the 3rd step. So looks like I solved the truss 2 times. The first time due to the given load. The second time when I removed everything and I put unit load. So I solved the truss one more time. The last step, your deflection at point B equals summation N L over E A, and I will do it in a table. The first column will be the name of the member. We have member AB. We have member BC. We have member AC. We have 3 members. AB, BC, AC. That makes sense. What is the length of each member? AB is 10 feet. BC is 8 feet. AC 6 feet. What is the value of capital N? The force in this member, negative 250. The force in member BC, this member, positive 200. AC, the force in member AC was positive 150. Small n. What is the internal force in this member? Negative 1.67. Member BC, the force in this member, positive 1.33. The third member, this one, positive 1. Can you multiply this column by this column by this column to find capital N time L? Can you? So this value times this value times this value. We will have here 4,175, 2,128, 900. Can you make summation for this column? What is the summation? The summation will be 7,203. Your deflection at B equal summation NNL over EA. Okay. The numerator summation NNL will be 7,203 divide EA. If the EA is given in the problem, I can get you the final number. And your deflection at B is positive. What does it mean? I assumed the correct direction of the unit load, which is going down. So your deflection will go down. Correct assumption. So, how to use virtual work to solve truss is very easy, but longer. You need first to solve the truss due to the given load. We need to figure out what are the reactions and do joint equilibrium for each one to find the internal force in each member, which called capital N. Next step. You need to remove everything. If you remove everything, the reactions will be removed also. And I will put unit load at the point you are looking for. So we have a new truss right now under the effect of unit load. Go ahead and solve this truss one more time. So we need to figure out the reactions and the internal force in each member, which you call small n. The final solution or the final value, deflection at the point equals summation capital N small n times L divide EA. To figure out this term, we need to set up this table. Both the members of the truss, each member. What is the length? What is the capital N value? What is the small n value? And go ahead and time. Multiply this column by this column by this column and put it here, here, here. Get the summation of this column. This summation called summation n times L, which is the denominator. The numerator. Divide EA. If your value is positive, you assume the correct direction down. If your value is negative, you assume the wrong direction should be up.